you already know about the face-to-face? Yeah.
Dengar sikit-sikit je.
Oh, dengar sikit-sikit lah, macam tak confirm lah. Tapi I think it's pretty confirmed dah kot at this point sebab dah masuk meeting pengurusan. But anyways, that was from my boss lah. And then test is on week 13, face-to-face, and then the class proceeding after that week is hybrid mode, which means that you will alternate between having physical class and online class. Sebenarnya susah untuk kita orang, sebenarnya susah untuk lecturer because we have to like prepare like different lectures untuk physical, different lectures untuk online. But it's better for you guys to like understand the content sebab depan-depan belajar lagi senang kan. So it's better to have the hybrid mode instead of just online. So hybrid mode ni until week 18. Okay, sampai week 18. And then week 18 is week 19. When week 19 is not on the calendar. But after week 18, which is not on the calendar, and week 19 does not exist sebenarnya, you have your finals. And this is also face-to-face. Oh, before your test, you have muat. Good. Tapi tak tahu tu week berapa. Week 12 ke? Week 13, tak sure. Okay, tapi kita punya test is on week 13. The date for physics is already locked. So by that, week 13 tu memang confirm lah. Week 13 is confirmed for the test. Dan memang dah ada lock date dah. So you have your muat test and then your hybrid mode class and then your finals face-to-face. And then kita habis asasi. So just make sure if you don't get an A or a B, make sure you pass my class, okay? So I don't have high expectations, but I want you to score lah, of course. But if it's not your thing, it's okay, all right? All right, so kita akan belajar chapter 16. As I mentioned before, if you have questions on chapter 15, please personally WhatsApp me. I will kumpul all the questions and we will answer them in a tutorial, okay? Why is it important? Because it will be on the test, for sure. Oh, kita dah start recording ke? Sejak bila saya record? Did I record it since tadi? This is so scary. Okay, never mind. Okay, so we are doing chapter 16, which is on electrostatics. And kita dah belajar we have learned about hydrostatics. Hydro means water, static means, what does static mean? What does static mean?
Bergerak.
Tak bergerak, or it is in equilibrium. There's no acceleration lah. Okay, so electrostatic means electricity and no acceleration. That a simple explanation of that. Okay, let me use pink. Okay, so for this chapter, we will be learning about electric force and electric field, electric potential and potential energy, and charged particles in electric field. Ada orang menyanyi ke? Okay.
Fakri.
Okay. Nanti boleh share dalam kelas. Okay, betul kita ada electrostatic. The word electrostatic is a combination of two words, electro, charge or electron, and static, stationary state. You know this. Electron is a Greek word meaning amber, pale yellow. I also don't know if this is important. I don't think it's important to know this, but this is what it means lah sebenarnya. Dulu orang Greek cakap, okay, electron ni pale yellow. So let's just call it that. I don't know. Okay, so Benjamin Franklin demonstrated the existence of negative and positive charges. So this dude is the reason why we are suffering learning this, okay? So don't blame me on this one. Moving on. Okay, point charge. So we have Charles Coulomb. Charles Coulomb came up with Coulomb's law. He decided to study about electrical forces, electrical fields. So he developed the Coulomb's law. This is sorry, that was my WhatsApp. This forms the basis for this chapter lah, Coulomb's law. Describe the electrostatic force of attraction and repulsion. We will learn about this more. First law of electrostatics. Unlike charges attract and like charges repel. Kita akan tengok examples on this, pretty easy. There are two types of charges, negative charges and positive charge. So this is negative with the negative sign, positive charge with the positive sign. This is also called an electron, and this is also called a proton. Okay, so the charge value for electron and proton are the same, which is 1.6 something, I don't remember. Ada tak kat sini? Okay, so it's here. The value of E is 1.602 times 10 to the minus 19 C in SI unit. The value for charge of an electron is this much, Coulomb. The value of a proton charge is also this much in Coulomb. So value dia sama. Apa yang membezakan a positive charge and a negative charge is of course the signs. So value for electron is minus 1.602 times 10 to the minus 19 C. And for proton, okay, positive. Sama je. Okay, so it doesn't matter whether the question is talking about positive charge or negative charge. This is the value that you should use, okay, which is E equals to 1.602 times 10 to the minus 19 Coulomb. C is Coulomb. The SI unit for charge is Coulomb, or capital C, not small c, capital C. Okay, now let's take a look at this equation. The amount of charge Q is measured by the number of charged particles. So let's say I have an object. This object, okay, let's just go for we have a ball here. Let me think of it. Okay, kita ada ball kat sini kan, on my right. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 electrons in this ball. And we have 1, 2, 3, 4, 5, 6 protons in this ball. So if I wanted to know what is the charge of this ball, I would say, so the charge of this ball is Q equals to NE. I have 8 electrons, so 8 times 1.602 times 10 to the minus 19 C. And whatever that value is the charge of my, where is my calculator? Done. Whatever that value is, that is the value of the charge of the ball. Okay, so let's see, 1.602 times 10 to the minus 19 C times 8, right? Because we have 8 electrons, sorry. So that is 1.28 times 10 to the minus 18 Coulomb. So I ask you, okay, what's the charge of this ball? So you answer me, okay, it's 1.28 times 10 to the minus 18 Coulomb. What's the sign? It's a negatively charged, hello, it's a negatively charged ball. So it should have a negative sign. Silap pula, sorry. Okay, it's a negatively charged ball. So this guy is a positively charged ball. So again, Q equals to NE. Walaupun tulis E, tapi it can refer to proton or electron. E is just a constant, which is this guy. Okay, so we have 6 positive 1.602 times 10. Apa tadi? 19, minus 19. Okay. So whatever the answer is, it should be in Coulomb. That is your SI unit. Okay, I hope that's clear. So that was Q equals to NE, our first equation for this chapter. Okay. So a conducting sphere has a net charge of minus 4.8. Immediately, we already know that it is negatively charged. What is the approximate number of excess electrons on the sphere? So it's asking how much E, how much electrons are there. So kita tahu equation dia, which is Q equals to NE. And we know what is the Q, which is minus 4.8 times 10 to the minus 17 C over the charge for 1 electron, which is 1.602 times 10 to the minus 19 C. So C cancels out with C, which gives me the number of electrons. So here I have minus 300, which just means that I have 300 electrons. Okay, excess of electrons. If you have any questions, you can ask me, okay? Okay, moving on. An aluminum nail has an excess charge of positive 3.2 microcoulomb. What does micro mean here? Or is it nano? Is this a symbol for micro or is it the symbol for nano?
Micro.
Micro. How much is a micro?
10 to the power of
10
6.
negative 6.
Negative 6. Okay, so micro is 10 to the minus 6. Nano is 10 to the minus 9. Okay. Okay, saja nak revise dengan korang. Let's use red. Okay, how many electrons must be added to the nail to make it electrically neutral? Okay, so previously I talked about this dude having this much electrons and it is negatively charged. Ya, Fakri, soalan ke? No?
No, to take mic. Sorry.
Okay, it's all right. So we have 5E, which is negatively charged, right? I need to add positive 5E to make this guy A0, which is neutral. So if I were to add positive, 1, 2, 3, 4, 5 kan? Okay, so kena tambah 5 lah. Then the number of electrons balances out with the number of protons, which means that there will be no excess charge, either positive or negative, sebab dia cancel out each other. So tertinggal satu. Okay, so the number of protons and the number of electrons, if they are the same, they cancel out each other, which makes the object neutral. Okay, now kita punya soalan cakap we have positive 3.2 microcoulomb. How many electrons must be added to the nail to make it electrically neutral? Which means that I have to add the same amount of electrons to balance it out, right? So plus 3.2 minus 3.2 microcoulomb makes it a 0. So Q equals to NE, this should be minus 3.2 times 10 to the minus 6 coulomb, and divided by the charge of a proton, which is 1.602 times 10 to the minus 19. Kat sini dia abbreviate, dia buat satu decimal point je. Okay, so 1.602 times 10 to the minus 19C. So we cancel this out and we get the number as 2 times 10 to the 13, which gives us the number of electrons to make the object neutral. Okay, must be added to the nail to make it electrically neutral. So far senang je kan? Q equals to NE je. Okay, if you have any questions, feel free to ask. Okay, so that was Q equal to NE, and tu je yang kita belajar so far. We are moving on to electric force and electric field. So in this subchapter, we are learning about Coulomb's law, and then we will calculate force due to a single charge, calculate the resultant force due to a number of charge. So tengok resultant je dah tahu dah, okay, it's a vector. We will learn about vectors again. And define electric field, calculate electric field due to a single charge, calculate the resultant field, which is also a vector. And then draw the electric field lines for a simple system of charges. So I would say this subchapter deals a lot with vectors. So it's time to brush up your vector skills. Okay, so electric force can be attractive or repulsive between two charged objects. If they are different, negative with positive, they attract. If they are the same, negative with negative, they repel. Positive with positive, they repel. Repel ni maksudnya tolak lah. Okay, repel, tolak, attract, tarik. Okay, the force is a field force that can be exerted even if there is no physical contact. which means that they don't have to be in touch with each other for the force to happen. Unlike, okay, I'm not going to compare with anything. So you don't have to have contact lah for electric force to happen. The force is a field force that can be exerted even if there is no physical contact. The force between the charges are mutual force. If this guy is exerting F1 force, this positive guy will be exerting F2 force, and these forces will be the same in magnitude, but in opposite direction. So F1 is equal to F2, but in opposite direction. Okay, this is Newton's third law, remember? Newton's third law. Kalau ada force, dia akan, what was it? Forgot. Newton's third law, but you know this. This is the equation for Newton's third law. I forgot what he said exactly. Okay, so if I am repelling by F1, this dude will be repelling by F2, but it has the same magnitude, but different direction. Sama juga kat sini. F1 is equal to F2, but different direction. Okay, so force is a vector, you know this already. There will be a magnitude, there will be a direction. Okay, nanti kita akan belajar why this is important, this repel and attract. Okay, so Coulomb's law shows that an electrical force has the following properties. So F is inversely proportional to square of a distance. Force is inversely proportional to the square of distance. So the greater your distance, the greater your R, the smaller your F, because they're inversely proportional. When we have an inverse equation, when something increases, the other guy has to decrease. When something decreases, the other guy has to increase because the inverse. And electrical force is also proportional to the product of Q1 and Q2, which is charge 1 and charge 2. So this is the symbol for a charge, Q. Small q or capital Q, dua-dua boleh. So you can say F Q1, Q2, boleh. It simply says F is proportional to the product of two charges. So in this case, if it is proportional, if my charge has a big value, my force will also have a big value. If my charge has a small value, my force will also have a small value because they're proportional. Okay, so this is what Coulomb said. They study and then this is what he found. And with these results, he came up with the Coulomb's law equation. Okay, which is force is equal to Q1, Q2 over R squared. Okay, remember force is proportional to the product of two charges and inversely proportional to the square of a distance. And this K is the Coulomb constant, which is 9 times 10 to the 9 Newton meter squared per Coulomb squared. Okay, so let's take a look at this one. So if I were to plug in K punya units, Newton meter cube over Coulomb squared. Charge, the SI unit for a charge is Coulomb. The SI unit for another charge is also a Coulomb. And R squared, which is the distance squared, the unit for that is meter squared. So what am I left with? The squared cancels out CC with C squared. So I'm left with Newton. So this equation will give me Newton, which is the force, the Coulomb's force, the electric force, okay? Where epsilon naught. Epsilon naught is the permittivity in free space. What is permittivity? Permittivity comes from the word permit. How much electricity ya Allah teruk ni tulisan. How much electricity does free space permit? Okay, how much does it permit? How much electricity does it permit lah, because it's called permittivity in free space. So this is epsilon naught. This is how you spell it if you're interested to know. So this is epsilon naught. It is the permittivity in free space. This is the value. I don't suggest you to memorize it. Just know this guy. Okay, so K is equal to 9 times 10 to the 9 Newton meter squared over Coulomb squared. Okay, and K is made up of 1 over 4 pi epsilon naught. We don't have to memorize it. It's a constant. Okay. Okay, so the Coulomb's law equation gives us the magnitude. Why? Because when we use this equation, we don't care if the Q1 is positive, if it's negative, or positive with positive, negative with negative, positive with negative, we don't care. We use this equation to find out the magnitude of the force only. I know force is a vector, right? Force is a vector, but this equation only gives us the magnitude. So where does the direction come from? It comes from the attract and repel that we have learned previously, just now, baru tadi. Kalau lupa, baru tadi belajar. Okay, so this guy gives us the magnitude. Wait, G tu apa? So this guy gives us the magnitude. Okay, so let's talk about the direction. So positive with negative, it will attract, it will tarik. So I will be attracted to this negative guy. That sounds wrong. But the positive charge will be attracted to the negative guy, and the negative guy will be attracted to the positive girl. I would say girl, positive girl. Okay, tak ada. No. Everyone's positive here. Okay, so positive attracted to negative, negative attracted to positive. So if I were to ask you, what is the direction of the negative charge? The direction of the negative charge is to the left. To the left. The direction of the negative charge is to the left, but the direction of the positive charge is to the right because they are attracted to each other, right? So this determines the direction. This is the direction of your force. Okay, so first kita dah cakap pasal magnitude, which is given by the Coulomb's law. The direction is given by the signs. If it's a positive with a positive, it will repel. If it's a negative with a negative, it will repel. If it's a positive with a negative, it will attract. Okay, like charges repel, different charges attract. Okay, so I hope there is an example after this. Okay, kita cakap lagi pasal ni. So electric force due to a system of charge. Just now we talked about if we had negative and positive, which is just two charges, right? What if we have more? What if we have 3? What if we have 5? Okay, so this is where the vector equations come. Okay, banyak lah. So electric force due to a system of charge. So the resultant force, when we have vectors, we most of the time we have resultant on any one charge equals to the vector sum of the forces exerted by other individual charges. Okay, so here kita tengok example ni. I have Q1, Q2, Q3. I am interested to know what is the resultant force, what is Fr on Q3. But who is exerting the force on Q3? This guy is doing something to the guy. This guy is also doing something to the guy because they are like close to each other, right? So the positive charge can either attract or it can either repel depending on what the sign of Q3 is. Okay, so now kita punya sign of Q3 kita negative, which means that it will be attracted to the positive charges. So negative will be attracted to positive charge. Negative will be attracted to positive charge. So I have one force here and another force here. Okay, in this case, orang ni dia label F31, which is the correct way to label it. So let's write that back. Okay, so this is the proper way to label it. So F31 means the force exerted by 1 on 3. F31, the force exerted by 1 on 3. The force exerted by 2 on 3. Okay, so the force, this negative guy is attracted to here, to the positive guy, and this attracted juga. So I have one force to the right, I have another force to the left. So what is the resultant force? It should be the summation of these two vectors. Okay. So let's just say, so F31 is force. So this guy, dia punya arrow lagi besar. Let's say it's a 5 Newton. This arrow is a little bit smaller. Let's say this guy is 2 Newton. So F31 is going to the right. So by convention, by typical convention, I would say going to the right is positive, going to the left is negative. So F31 is positive, F32 is negative. So here, my answer should be 5 minus 2, which is 3 Newton. The answer is a positive, which means that the resultant force on Q3 is to the right. Is everyone okay so far? Is everyone following me?
Yes.
Yeah, no questions? Okay, so everyone's okay, all right. So that is one example. So let's move on to the next one. Just down here. Just rabut sikit gambar ni kan. Okay, so resultant forces on Q2 particle is given by this equation. So I am interested to know what are the forces exerted on this guy by these two charges. Okay, walaupun this negative guy is like hujung sana and there is a positive charge in between, it doesn't mean that there is no force exerted. Still ada force. So positive with the negative is attracted. So attracted, which means that I want to go to the right. Okay, and positive with positive. So wait, this is charge Q1, right? So one on 2 to the right. And then this guy is repelling this guy, which means that it will go this way. Dia repel, dia tak nak, dia tak suka, dia tolak. So this is the direction that he will go. He pula. Positif perempuan kan? She. Tak adalah, tak ada gender sorry. So dia akan pergi, this positive charge will want to go to the left, right? And this is F2 by 3. This is the force exerted by charge Q3 on charge Q2. Okay, so now we have two forces. This is the equation. So the resultant force on Q2 is equal to F21 plus F23. Do you have to label the signs in this equation? Not necessarily. If you want, you can, but the signs will come when you put in the magnitude. Okay, boleh juga. So let's say I want to say F21 is 5 and F23 is 3. Sama macam tadi, ikut yang tak, okay lain sikit. So positive 5. So the signs come when I put in the magnitude, right? And minus F23, 3. Okay, so you can put in the signs when you put in the magnitude. Or you can put in the signs when you write the equation. Pun boleh juga. But saya rasa it gets a little bit confusing if you put it here. So my suggestion, just keep everything positive for the resultant equation. Sebab nanti nak resolve jadi XY. This is one dimension, senang. When it comes to two dimension, it will be a little bit tricky. Okay, so last one for a single dimension. So I want to know what is the resultant force acting on Q3. Acting on Q1. So I want to know what's going on Q1 with Q3, what's going on Q1 with Q2. Diorang gaduh ke? Diorang baik. So Q1 with Q3 kamcing, dia nak attracted. So dia akan pergi ke arah Q3. Q1 with Q2, negatif dengan positif, kamcing, go. So both forces are going to the left. Both forces are going to the left, which means that my resultant confirm to the left. Ini senang lah, soalan yang senang. So F12 plus F13, direction final resultant is to the left, whatever the magnitude is. Tambah je. Ni one dimension, senang. Okay, so now we have electric force due to a system of charges, and this time our charges are not located on a single axis. We have X and Y lah. Okay, so what have we learned so far? Let's take a look at this one. Like charges repel, opposite charges attract. This determines the direction of F. Coulomb's law equation gives us the magnitude of F. What is Coulomb's law? F equals to K Q1 Q2 Q2 over R squared. Remember, it's proportional to the product of Q1 and Q2 and inversely proportional to the distance squared. Squared is very important. Don't forget your square. Okay, and then we have the K. K is the Coulomb's constant, 9 times 10 to the 9 Newton meter squared over C over Coulomb squared. Okay, and then F resultant on a charge is the summation of F as vectors. This is called the superposition principle. You don't have to know it. You just have to know how to add things that are vectors. Okay, you don't have to memorize this name. It's not important. What's important is knowing how to add vectors. Okay, okay, so here I want to talk about this guy. Like charges repel, opposite charges attract. Direction of F is along the lines. So as you can see here, we draw lines first. I don't care if the signs yet. I'm just drawing lines first. Okay, now I'm interested to know what is the resultant force acting on Q2 by Q1 and Q3. Kita tukar sikit soalan. What is the resultant force acting on Q2 by Q1 and Q3? Okay, so tadi saya dah draw line. Now I have to decide what is the direction. So positive charge is attracted to negative charge. Tak nampak lah pula green. Sekejap, tukar. Let's use pink. So positive charge is attracted to, oh I think kena tebalkan sikit kot, tak nampak. Baik kau. Okay, so positive charge is attracted to negative charge, right? Positive charge is it attracted or repelled to this positive charge? Is it attracted or repelled, guys?
Repel.
Repel. So which way should I go? Should I go like this? Should I go to the right? To the left? Which way should I go? Ooh, no one's answering. Okay, so remember I told you, okay, tak ada remember. Just now I told you we draw lines first, right? So this is the importance of drawing the lines. I know where to draw my force. If it is attracted, it will go this way. If it is repelled, it will go the other way. But it should be along the lines connecting both charges. Okay, I'm going to repeat myself. First, you draw the lines, then you decide if it's attracted or repelled. Then you draw the arrow along the lines. So in this case, it's a positive with a positive. So it is repelled. So it will be pushing, but it will be pushing along this line that connects these two charges. Okay, so saya tanya lagi satu soalan. So let's say I have another charge. It's called Q mystery. Okay, tak tahulah value dia apa semua kan. This Q mystery, kita tahu dia, it's a negative sign. What is the direction of force exerted on Q2 over here? How should I draw it? No one wants to try? Okay, saya kasih first step. So I have to draw a line. What's the next step? Is it attracted or repelled?
Attracted.
Hmm? Yes, Christina?
Attracted.
Attracted because it's positive with negative. So with that in mind, I have to draw my force along this imaginary line that I drew. So this is the force by Q mystery on Q2. Does that make sense? Is everyone okay with that step? Is everyone okay with that step?
Yes.
Mana nak buat?
Yes.
Yeah. Draw a line, determine whether it is attracted or repelled. Then you tackle the magnitude of the force, which you use the Coulomb's law equation. Nanti kita akan buat example in a bit. But understanding how to draw this diagram is very, 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 very important. Okay, moving on. Hello, stuck pula. Alright. Terlupa lah. Sekejap, Let's do this together. So this is an example. So the magnitude of force on each charge of equal charges. Wait, on equal charges. It says that we have equal charges separated by 1 meter apart is 9 times 10 to the 9. So magnitude of force F equals to 9 times 10 to the 9 Newton on each charge of equal charges. So kita tahu if we have F1 here, we also have F2, but F2 is actually the opposite sign of F1, right? This is in the case of two charges lah. They are of equal charges. So if this guy is Q1, this guy is also Q1. Okay. Buruknya jap. Excuse me. Let me make this nicer. Saya pun sakit mata. Okay, so F1, F2, Q1, Q1. Because why is it both Q1? Because they are equal charges. And then they are separated by 1 meter. So from the center, they are 1 meter apart. Okay, what is the magnitude of each charge? So here we have the magnitude of force. I know that Q1 is equal to, Q1, both are having the same charge, and I know what is the R. This is our R, right? So let's try using Coulomb's law. So Coulomb's law equation is F equals to K Q1 Q2 over R squared. We know K is 9 times 10 to the 9 Newton meter squared Coulomb squared. Q1, I don't know this value, and I know Q2 is actually just Q1. If I wanted to say both are just Qs, I can do that. If I wanted to say both are Q1, I can say that. Boleh je, tak kisah. So Q1 squared. I'm just going to say they are both Q1. And then over R squared. And we know that our R is 1 meter. So this is just 1 squared. And I know that my F is 9 times 10 to the 9 Newton. Betul ke? K sama dengan tu? Sekejap, saya check balik. Oh, it's 9 times 10 to the 9. Oh, betul. Okay. Alright, so now this is our equation. We know the F, we know the K, we don't know the Q, we know the R. So 1 is just 1. This guy, if I bring it to the other side, it will just give me 1. This is Q1 squared. This is Q1 equals to 1 Coulomb. Is that the answer? Let's see. Yeah, it's true. So the answer is 1 Coulomb. Peliknya soalan ni. Okay, so using the Coulomb's law equation, 9 times 10 to the 9 equals to blah, 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 Q1 squared. So I solved for Q1, which is 1 Coulomb. So this guy has a charge of 1 Coulomb. This guy has a charge of 1 Coulomb. This is how you use Coulomb's law equation. Okay. Oh, sorry, they are equal, so they should not be attracted. My bad. Salah ni. So this is F1, this is F2. Oh, this is a grave mistake. Forgot. Okay, so like charges repel. So they are repelling each other. Okay, nasib baik tak ada signs in this question. Okay, so with that said, we need to be mindful of the signs. Okay, moving on. Oh, we have another question. Let me duplicate this. Any questions so far? Is everyone okay? Okay, now that we made that mistake, so now we have to be more careful. So 3 charges are arranged linearly on a vertical y-axis. Vertical y-axis. So vertical means menegak lah kan? On a vertical y-axis, given that Q1 is 4 microcoulomb. So let's draw it in a different color. So this is my Q1. I don't know where it should be. So this is my Q1 and hopefully this is Q1, Q2 and Q3. Kenapa saya susun macam ni? Because this question says 3 charges are arranged linearly on a vertical y-axis. Q1 is ada direction. Q1 is 2 meter above Q2. Q1 is 2 meter above Q2. Let's draw that. So here, like that. So this is 2 meter above Q2. And Q3 is 4 meter below from Q1. So Q3 is 4 meter below Q1. Oh, silap. Okay. Do I want these diagrams in your test? Yes, please draw these diagrams. So 4 meter. Selalunya kalau orang tak lukis memang salah. Selalunya lah. Ya. Kalau genius dia boleh kira dalam otak dia, tak apalah. Okay. Tapi saya pun tak sampai level tu. Saya kena lukis juga. So Q1, Q2, Q3. So Q1 is 2 meters above Q2. Q3 is 4 meters below Q1. Okay. Find the force on Q1. So what is the charge in question? It's this guy. We need to use a different color. It's this guy. I am interested in this guy. I want to know what are the resultant force on Q1. Okay. Now let's put in the values. This is a positive. Q2 is a negative. And Q3 is a positive. Okay, so now let's talk about the direction. Okay, nak tanya siapa? Nak tanya Hikmah lah. Hikmah, what is the force exerted by Q2 on Q1? Kalau tak nampak ni. Positive. What is the force exerted on Q2 by, what is the force exerted on Q1 by Q2? What is the direction? What is direction? Line kita dah ada. I just want to know if it's going up, going down, going right, going left. Okay, is Hikmah there? Hikmah is gone. Saya tak dengar. Hikmah is missing in action. Okay,
Hikmah sit down.
What?
She's typing in the chat box.
Okay, kejap. Where's the chat? Okay, it's here. Oh, ada 4. Ush. Sorry. Raya boleh balik ke doktor? Saya tak tahulah. Okay, doctor, you said just now that E should be negative or positive according to the electron or proton. But why in the calculation, if we want to find n, we don't put the sign positive or negative for the E? You can put in the sign. The others, there was some example there where I put in the sign. There are some examples where I don't put in the sign. Ultimately, you need to know whether it's a proton or electron, and your final answer adjust accordingly lah. Okay, tapi it's much safer to put in the signs early on lah. Okay, so that's the safe route. Down, hikmah is down. Oh, down, okay. Sorry. So the direction is down. Umar, doctor, is the charge move from negative to positive or positive to negative? Maksud Umar apa?
Untuk direction dia tu. Positif ke negatif atau negatif ke positif, Doktor?
Okay. So I ask you what is direction on Q1, right?
Ya.
Okay. Previously I talked about Newton's third law. If I have contoh, if I have force 1 exerted by Q2. Kenapa lah warna-warna yang saya pilih ni tak membantu keadaan. Kejap Okay, choose carefully. Okay, it's a blue. So if I have F1 from Q2, I will have the same F exerted on Q2. Faham tak? I'm talking about Q1. I want to know what is the force exerted by Q2. So this is the direction. Okay, kita buang dulu line dia. Okay, let me refer. Kejap. Need to explain this carefully. Group. Let's put in some more space. Okay. So tadi I told you draw a line connecting all the charges. Okay. And I wanted to know what is the force acting on Q1. And Hikmah said the force acting on Q1 by Q2 is going down because it is attracted to Q2. So this is the direction of F1 by 2. Now Umar asked, does the positive charge go to the negative or the negative charge goes to the positive? The answer is it depends on the resultant force. But if we are talking about two charges specifically, and if they are attracted to each other, they are both moving. Sebab dua-dua attracted to each other, so they are going to move. Dua-dua akan attracted to each other, they are both going to move. But since we are talking about Q1 only, we want to know what is going on Q1 only. We are zooming in on Q1. I don't want to know about Q2. I don't want to know about Q3. I want to know what is going on Q1. That is where the effects are coming from other charges. I want to know what's going on with Q1. So that question tells me that I should only focus on the resultant forces acting on Q1. And the direction of Q1 is determined by my resultant force. Faham tak? So if I change this question to Q2, find the force on Q2, I would have the same force, F21. I would have the same force because now I'm talking about Q2. So sebenarnya dua-dua force ada and they will both move towards each other. But that is not the point of the question. The point of the question is finding the resultant force acting on a charge. Okay, faham tak? Okay kan? Okay kan?
Okay, Doktor.
Okay, so I hope that's clear sebab selalunya orang akan confuse find the force on Q1 but they will tell me what is the force acting on Q2. So that is not what the question is asking. It's asking about Q1. So we are just focusing on Q1. So what is acting on Q1? So it will be attracted to Q2. Okay, so anything, the question is about Q1, semua datang daripada Q1. Semua atas Q1 sahaja yang saya nak tahu. And Q3, it should be repelled, right? Because it is light charges. So this guy, let's say this is F12 and this is F13. Okay, sebab repel. So it will be pushing away from Q3, F13. F12, it will be attracted to Q2. So F12 going down. Okay, everyone okay so far?
Okay.
Okay, all right, so now we know that this is our direction. Next step is finding the magnitude. So finding the magnitude, F13 equals to K Q1 Q3 over R13. The distance from charge 1 to charge 3 squared. Do not forget the square. So this is, I told you, you don't have to care about the signs in this equation. It only gives you the magnitude. The direction is given by your diagram. So K is 9 times 10 to the 9. Q1 is, my face is blocking it. So that is a 4 times 10 to the minus 6. Everything should be in SI unit. R1 to 3 is 4 meters. So that is already in SI. So 4 squared. So this will give us our F13. Can someone calculate that for me? And then the next one is F12. Kita dah buat yang atas ni, kita buat yang bawah pula, F12. So that is K Q1 Q2. So sini satu Q1, 2 Q2. And then this should be R12 squared, the distance between charge 1 and charge 2. The distance between charge 1 and charge 2 is 2 meter. So senang je. 9 times 10 to the 9. Q1 is 4, tinggal Q3 pula dah. Q3 apa? 6 times 10 to the minus 6. Okay, so 4 times 10 to the minus 6. And then our Q2 is minus, sorry, it's a 5 times 10 to the minus 6. Okay. Jawapan untuk F13 ada orang kirakan tak? Malasnya kan. Anyone yang baik dan cantik dan comel dan handsome? Anyone? And F12 please. This is over 2 squared. Okay. What's the answer for this? No one is cute and handsome and pretty.
0.0135.
135. Thank you. Haziq yang tadi.
Umar
Ambil.
itu.
Siapa? Umar? Oh, Umar. Okay, thanks Umar. Nak kena cakap handsome ke? Cik, tak ada. Main-main je. Jangan malu. Okay,
No.
so 0.0135 Newton is a force. Okay, so force, what is the direction? F13, the direction is going upwards. How do I know this? I look at my diagram that I drew. If you did not draw a diagram, then you would know the direction. Okay, F12, what is the answer?
0.045.
0.045 Newton. Okay, thank you Shasha, yang cute, Umar, yang handsome. So we have our magnitudes, we have our direction. Now it's time to add these two forces together as a vector. So my resultant force on charge 1 is equal to, resultant on F1 is equal to vector F13 plus vector F12. And this guy is 13 is going up. I'm just going to assume that's a positive and going down is a negative. So positive 0.0135 minus 0.045 Newton. So the answer here, it's a negative lah kan, because this guy is greater. Sebab saya nak jadi cantik pula, saya pula kira. 0.135 minus 0.05. 0.045. 0.45. Okay. Minus 0.0315 is the answer. Sekejap adjust sikit. Oh, tak apalah, terambil sikit. I am sorry. Calculation over here. Okay, so the answer is minus 0.0315 Newton. Ya Allah, ya Allah. Okay, that's the answer. So with that said, the resultant force is a negative, which means that the direction of my force is going down, and the magnitude is 0.0315. Hopefully that's correct. Okay, betul. 0.0315 times 10, sorry, betul lah. Negative sign shows the direction of force is downward. Okay. Okay, thank you Dr. Nat yang cantik dan comel sebab saya jawab soalan tadi. Okay, next. Oh, lagi banyaknya. Okay lah, sini penting. Okay, duplicate slide. Do you guys want to try this one yourself? I think you should. Alah, dah ada jawapan kat sini. Buang. Sekejap. Okay. Okay, so this is the diagram, basic diagram. You need to learn how to draw the direction of F for this diagram. Okay. 3 charges are arranged as shown in the figure. Find the magnitude and direction of electrostatic force on the 6 nanocoulomb charge. Which one is it? It's this guy. So this is the charge in question. I want to know everything that's going on with this charge. I don't care about everyone else, just this charge. So all the forces should come or should be focused on this charge only. Okay? Okay, tapi macam nak suruh korang buat ke? Tak apalah, saya buat lah. Okay, so 6 nanocoulomb. It's a positive charge. 3 nanocoulomb. It's a positive charge. Positive. What was the first step of this to do this kind of problem? Draw the lines. Draw the lines. Okay, so since I'm interested to know what is going on with this 6 nanocoulomb charge, all my arrows should be focused on here. So 6 nanocoulomb with 3, I don't like this guy, so it's going to repel. So along this line, it is going to repel. And then 2 nanocoulomb charge, positive. I don't like this guy. He seems shady. So along this line, I am going to repel. So let's say this is Q1, this is Q2, this is Q3. I want to label this F lah. So F, this is Q3 on Q2. So this is 2, 3. This is from Q1. So this is F2, 1. So I have 2 forces. So that is my direction. I have the direction now. My equation should be resultant F2. I want to know about F2, right? The resultant force on F2 is equal to F23 plus F21. But now, instead of a one axis, either X or Y, we have X and Y here. So F23 kita ni ada angle. Maksudnya bila ada angle, kita ada X and Y, right? Okay, so next step. We already tackled the direction. How did we find the direction? Kita draw a line, draw arrow. Okay, good. Next one is using the Coulomb's law to find the magnitude of F23 and F21. So F23 is equal to K Q2 Q3 over the distance R23 squared. What time is it? Ooh, okay. After this question, we will take a break, okay? Okay, so sabar jap. And the magnitude for F21 is equal to KQ2 Q1 over R21 squared. Okay, so can anyone tell me what is the distance between charge 2 and charge 3? What is the distance between charge 2 and charge 3?
0.71 meter.
0.71 meter. Umar cari macam mana? How did you find it?
Theorem Pythagoras.
Theorem Pythagoras. Okay. So Umar found out the length here. Silap. Saya patut label R23. So Umar found R23 by using the Pythagoras theorem. So 0.5 squared plus 0.5 squared. Square root that will give you R23. Betul tak? Betul tak Umar? Is that how you did it?
Yes.
Okay. So squaring that will give you 0.707, but I want it in squared form. So the answer should be, for this guy, is already 0.5. What about the distance of R21? Can I get Jaya to help me? What is the distance between charge 2 to charge 1? Balik. Charge R23, R21. Jaya, are you there? Apa? Tak dengar Jaya? What's the answer? I mean, what's the distance between Q1 and Q2?
Sama.
Sama. Haikal jawab sama. Sebab
Sebab jarak dia sama.
jarak dia sama. Okay. So value Pythagoras theorem ni pun 0.5 squared plus 0.5 squared. 0.701. That's your answer there.
0.71.
0.71. Okay, thank you Jaya. So, Jaya said is 0.71 and Haikal, tadi Haikal kan? Haikal pun jawab sama. Okay, so 0.71. 71, when you square that, it will give you 0.5. Okay, so now let's substitute the values. K is 9 times 10 to the 9. Q2 is 6 times 10 to the minus 9. I think I will have trouble with space. Let's buat siap-siap. Sekejap eh. Duduk sini lah dulu. Okay. Okay, let's move it here. Okay. So 9 times 10 to the 9 times 6 times 10 to the minus 9, which is not 6 nanocoulomb. So this is my Q2. My Q3 is 2 times 10 to the minus 9. And then the distance as given by Umar and Jaya and Haikal are the same. So 0.707 squared will give you 0.5. Betul tak? Betul. Give you 0.5. So ni dah saya dah squarekan siap-siap eh. Kalau tak nak buat macam tu boleh 0.707. Boleh juga. Okay. So what is the magnitude for F23? Can someone find it for me while I write this down? Q2 is 6 times 10 to the minus 9. 1 is 3 times 10 to the minus 9. Let's see. Times 10 to the minus 9. Okay. Divided by same 0.5. So what's the answer?
F
3.24 times 10 power of negative 7.
Okay. Newton. And the other one, kira tak? Thank you.
Doktor. Yang tu kat bawah.
Oh, yang tu kat bawah. Okay.
3.2. Ah.
Okay. Yang atas punya, anyone calculated?
2.16.
2.16.
2.18.
16.
16. Okay. 2.18. Itu kawan ni pula. Jam. 16. Okay. Times 10 to the minus 7 juga ke?
Ah,
Okay. Thanks, Eka. Newton. Okay. So this is our magnitude. As a vector, we need to, what do we need to do with vectors? So how do I add two vectors, F23 and F21, if they are not in the same axis? What should I do? Okay, what should I do if I have two vectors that are not on the same axis? Ya, semua dah lupa dah vektor.
Buat yang komponen XY tu.
Komponen XY, yes, betul. Correct. Okay, so let me rewrite that kejap. So F23 is, anak saya dah balik lah. F23 is 2.16 times 10 to the minus 7. I should just copy that. Kenapa dah saya nak buat susah? Okay, is this copyable? Please be copyable. I am lazy. Okay, thank you. Korang dengar tak dia jerit?
Dengar.
Tadi dengar sikit.
Oh, dengar sikit. Okay, maafkanlah. Dia baru kecil. Dia baru kecil, dia kecil lagi. Dia sangat hyper. Okay, so F23 looks like that. Hello. Stuck pula. Okay. And then we have this diagram. Dah ada tak copy pula dah. I want this. Let me try. No. Okay, tak apalah. Saya lukis balik. Punyalah malas kan. Okay, kejap. Oh, tak boleh. Kena ada angle-angle ni. Yang payah ni. Okay, copy semua. Okay, so I have the magnitude and I have the diagram here. Now, Mariam kan tadi. Mariam told me, she told the class that we need to resolve vectors into the X and Y components. Betul. So let's do that. So X and Y. What is the component of X and what is the component of Y for both of these vectors? So F23 and for F21. Okay, let me draw the table. You don't have to make a table to answer the exam. I just want to make this as organized as possible because we all know I'm not very kemas. So F23, X component of that will be, what is the angle? Where is the angle? So this is where we zoom in. What is the angle that I need to know here?
45 degree.
45 degrees. So Umar said 45. Kat mana Umar nampak 45 tu?
90 divided by 2.
90 divided by 2. 90 divided by 2. Oh, okay. Sebab dia.
And house. House. Okay.
Okay, can you close the door, please? Thank
Hello?
you.
I want a house.
Okay. Sekejap, close the door, please. Thank you. Okay. Okay, so F23, Umar cakap 45. Any other guesses? Why is it 45? Can it be 30? Can it be 50? How do you get the angle? No one? So everyone agrees it should be 45.
Yes.
Okay, so Fakri pun agree it should be 45. Okay, so let's go with that. So 45. Now, what is the direction of x and y component for F23? What is the direction of x component for F23? Should it be to the right or should it be to the left? So here, this is my F. If I were to resolve it, it should be Fx over here and Fy over here. Fx 23, Fy 23. So here I know that my Fx should be positive, my Fy should be positive. Okay, positive and positive. What about F21? If I were to resolve my F21 into x and y components, I would see that this is my Fx for F21, and this is my Fy for my F21. Okay, so now I know that for my F21, my x component is a positive to the right, and my y component is negative, going downwards. Now that I know what the signs are, I can use the angle that I figured out, however I figured it out. Tapi Umar yang bagi tahu tadi, and Fakri. So now I'm just going to use it. So x component is F23 cosine of theta. Y component is F23 sine theta. This guy is F21 cosine theta. F21 sine theta. And theta is 45. We predicted that it's 45 lah. So F23 is this guy times with cosine 45. Let's calculate that. 2.16 times 10 to the minus 7 times with a cosine 45. Your calculator should be in angle, not in radians, should be in angle. So this would give me 1.52, 1.53 times 10 to the minus 7 Newton, and 2.16 times 10 to the minus 7 times with sine 45. I think it should be the same. Yeah, it's the same. 1.53 times 10 to the minus 7. Saya lupa lah tadi saya cakap nak kasih break kan.
Sign.
Okay. Okay, bye. Times 10 to the minus 7 Newton. Okay. Ouch. And then for this guy, sama, if we are assuming the angle is the same. Kejap. Okay, let's take our 5-minute break kejap. Kenapa budak ni? I close the door. Okay, bye. Okay, 5-minute break, if you guys need it. I know we learned a lot. So. One is 3.24 times 10 to the minus 7. Ada soalan tu. So 11:26 kita come back to class, okay? Doctor, for the degree we could determine using tan theta opposite over adjacent. Okay. Thank you, Umar. Okay, so this is Newton, this is Newton. So what is
Minus 2.29. 2.29. Sana kira. Times 2.40. Is it time yet? Okay, one more minute. Ush, termasuk electricity lagi. Siapa yang belum sign in attendance, please do so, okay? Okay, so, okay, time's up. Our 5-minute break is over. Hope that was enough. Pastilah, laju-laju sikit. Okay, so F, now that we know our F23, the X component of that and the Y component of that, and the X component of F21 and also the Y component of F21. So now we can add these two guys together and the Y components with the Y components. The reason why we resolve vectors into its X and Y components so that we have the how do you say it? We have the values in the same axis. So these two guys are in the same axis, which means that we can add or minus these two guys together. And Y dengan Y, dia kena sama axis. Kalau tak sama axis, tak boleh tambah. Okay? Okay, so this guy is positive 1.53 plus 2.4 times 10 to the minus 7. So this will give me an F2X component of plus 2.4, 3.93
times 10 to the minus 7 Newton. This is in the x direction for F2. For the y direction, we have a positive sign here, negative sign here. So this should be negative 1.53 times 10 to the minus 7 minus 2.4 times 10 to the minus 7. This will give me 1.53 minus 2.4 minus 0.87 times 10 to the minus 7. Kalau saya ada salah kira, bagi tahu. Okay, so now that I have the F2x, this is my F2x, this is my F2y. How do I find the magnitude of F2 and how do I find the direction of F2? The resultant force lah. How do I find that? Kita dah belajar semester 1. How do you guys find the resultant force magnitude and the direction? Ingat lagi tak?
Use theorem.
Use the Pythagoras theorem, okay?
Yes.
So the magnitude of F2 should be equal to F2x squared plus F2y squared. Okay, and square that. Square root that. So saya cakap square as root. So square root the whole thing. Okay, okay, saya akan buat je lah. Tak malas nak tulis. So F2x is 3.93 times 10. Can someone else please do this with me so that saya tak tersilap? Squaring that plus with 0.87 times 10 to the minus 7. Square that whole thing. Square root. I will get a 4. 4 times 10 to the minus 7 Newton. And what about the direction? The direction of F2. So inverse tangent, you guys don't remember, inverse tangent of F2y over F2x. The y component over the x component. And inverse tangent of that. So that will give you the direction. So F2y kita tahu it's a minus sign. And for F2x is a positive sign. So let me just draw that really quickly. So kalau tengok ni F2y is a negative, so it should be going down. F2x is positive, it should be going to the right. When I combine these two together, I have this and here. So my resultant should be located in this quadrant. So this is my FR direction. This is macam, how do I say this? This is how you check your answer. So I have a positive fx, negative fy. So this is my FR. This is how my FR should look like. This is how my resultant should look like. Okay, so that is my FR. Okay, so this is a negative and a positive. I don't know what the answer is. 0.87 divided by 3.93, right? So inverse tangent of that will give me 12.48. The angle that is given by this equation will always be with respect to the x-axis. Now, I told you this is how it should look like. So this is where the angle should be. It is always referring to the x-axis. Okay, whatever the answer here is lah. So here I got 12.48. Don't know if that's correct. Degrees. So that's the answer. This is how it looks like. Sorry, kecil. Besarkan sikit. Oopsie. Okay, so resultant force, positive x, negative y. This is where my resultant should be. This is the angle that I got. And it is with respect to x-axis. Right? Let's see if we got it right. The angle je terus. So this is negative and this is positive. So sama kat situ. So 3.82. Did we get 3.82? We got 3.93 and 0.87. Why is that? Kenapa ada perbezaan sikit-sikit? Let's see. So this is 3.24. Yang kira kat sini. Oh, dia pakai 0.707. By right, our answer should be the same. I'm not sure. Sekejap, kita punya value semua sama ni. 9, 6, 3, 6, 2. Let's see. 6.
Saya ada salah kira sikit dekat XY component tu.
Dekat XY component tu saya salah kira sikit. Okay, dekat mana
Yang
1, 3.
F21 tu.
F21 tu saya silap kira. Okay, 3.
Nilai dia doktor.
Nilai dia times cosine. Cosine 45. Sepatutnya berapa Oh,
Sepatutnya
2.29.
0.29.
Okay,
ah,
silap kat sini. Okay, so kita kena buat balik ke? Tapi korang faham kan? Korang faham kan how we should do it? Assuming that I did not mess up the time.
Faham.
Faham kan?
Faham.
Okay. So, untuk electric field, we will learn about this again. So, please bear with me if you still macam sama-sama about this. Bear with me dulu. Banyak lagi latihan macam ni. Okay, so moving on. We are moving on to electric field. We have half an hour. Okay, let's do this. Electric field is the area of influence of a charge. So if I have a charge, a positive charge here, right? I can say, this is my electric field, this is my electric field, this is my electric field from the positive charge, this dude over here. And then I have this negative charge. I can say, okay, this is my electric field from the negative charge. This is my negative field from the negative charge. This is my negative field. Sorry, this is my electric field from the negative charge. Boleh, it can overlap. Electric field comes from a source of charge. Sorry, electric field comes from a charge. The source is a charge. It can be positive, it can be negative. Electric field ni medan elektrik lah, medan, which means that you feel it, but you can't see it. What is an electric field exactly? Electric field is actually the force exerted on a unit charge. Kita belajar F. Kita belajar F, which is KQQ over R squared. Electric field is electric force over a unit charge. So with that said, why is my Q like that? KQQ over R squared divided by Q, this cancels out. This will give me KQ over R squared. So this is the difference between electric force and electric field. Electric force, KQQ over R squared. Electric field is force over unit charge. So kita kekurangan satu Q dalam equation kita. Kita ada satu Q je. KQ over R squared. Okay. An electric field is said to exist in a region of space around a charged object. So, okay. Why did I draw the electric field to be circular? Because the electric field depends on the distance. Okay, let me try. So if I were to say, what is the electric field exerted at this point versus this point, point A and point B, because they have the same distance to this charge, they have the same radius, right? They have the same radius or the same distance to the source charge. I can say electric field A is equal to electric field B. Okay, so the closer the point to the source charge, the greater the electric field. So if I were to say, what is at point C, is it greater, does it have greater electric field compared to A? Yes, because it's closer. So the closer you are to the source charge, the greater your electric field. Lagi dekat kita dengan source charge, lagi terasa lah, lagi kuat lah orang cakap kan. So electric field at point A and electric field at point B is the same because they have the same distance or they have the same radius to the source charge. Electric C has a greater magnetic field compared to EA and a greater magnetic field compared to EB. Okay, so here it says like charges repel, unlike charges attract. Nanti kita akan cakap pasal ni lagi. Kita belajar pasal electric field in general dulu. Okay, so electric field at a point is defined as E equals to F over Q. We talked about this, KQ over R squared. This capital Q is our source charge. Previously, when we talked about electric force, we did not define a source charge, but we define what is it that we want to take a look at, which charge that we are interested in. That was for force. Untuk electric field, we need to determine what is our source charge before we can solve the problem. Okay, so this is why dia buat Q besar. Macam besar lah, dia jadi source kepada medan elektrik tu. So the SI unit for electric field is Newton per Coulomb. So let's see how that is. Let's do dimension analysis because I like doing that. So K is Newton meter squared over Coulomb squared. Q is Coulomb, R is meter squared. Cancel that out, cancel out. So I am left with Newton over Coulomb. Or you can just look at this guy. Force is in Newton, Q is in Coulomb. Pun boleh. Okay. So the direction of the field is the direction of force on a positive test charge placed at that point. What does that mean? So if I have a source charge, positive Q besar ni, this is my source charge. Let me write that there. Source charge. Oh, kenapa pakai hijau? Tak nampak. Okay, so that is my source charge. Let me get rid of this. And I want to know what is the direction of electric field. I want to know what is the direction of electric field from this source charge. So how do I do that? I need to put a positive test charge. Selalunya dia akan cakap test charge je. Dia tak cakap positive. Test charge simply means positive test charge. Test charge is just basically a positive Q, a small Q, a very, very small value charge. Let's just assume it's 1 lah, supaya hidup kita senang. So test charge is always a positive charge and the value is super small compared to the source charge. So this is how we determine the direction of electric field. Okay, so how do I do this? So this is my test charge. Super small compared to the source charge. Ni source charge. Let me write that balik. This is my source charge. Macam sour lah. Source. This is not sour. This is source. Okay. Source charge, test charge. So Q to positive. Sorry, this is positive. This is also positive. So I will be repelling, right? I will be repelling. Repel because like charges repel. So the electric field lines coming from this positive source charge is like this. Okay, I have my tukang kacau is here. Sekejap. What time is it? Hello. What do you want? It's not even locked. Come on. Really noisy. I'm teaching. Okay. Okay, so because we said this is our so I'm teaching. Quiet, please. Okay, so we put a positive test charge and it is going to repel. So the source charge repel sorry. Tengok pada test charge. So the test charge will be repelling the source charge. So that is the direction of electric field. Can you sit over there, please? No, go away. Okay. Okay, I need to focus. Okay, next. Electric field at a point is a vector quantity. Jangan. No.
No. No. Don't cry.
Okay, don't cry. Okay, go sana. Go painting now.
No,
It's painting.
sleeping.
Okay, go sleep. Okay, so the direction of the field is defined to be the direction of electric force that would be exerted on a small positive charge. Exerted on the test charge that kita dah tengok tadi. For example, this is our test charge. What is the force exerted by the source? Because dia nak repel, this is the direction. Okay. So a positive test charge would be repelled from a positive source charge. Okay, sorry, pada distraction tu. Okay, so test charge, kita tengok direction of the force on the test charge. That is the direction of your field. Okay. And then this is another example. Our source charge is now a negative. And this is our test charge. Okay. So now I'm interested to know what is the electric field line on the test charge. So it will be attracted to the source charge because they are different charges. So this is the direction. Okay, so that is your electric field line. Direction of electric field. Okay, direction of electric field. Sorry, so I keep saying electric field line. Sebenarnya it's just the direction of electric field. Electric field line is a different thing. So abaikan saya cakap line, right? So it's just the direction of electric field. Okay. Okay, so electric field is inversely proportional to the square of the distance from the source. Why? Because our equation is E equals to F over Q, which is just KQ over R squared. Okay, so it is going to be inversely proportional to R1 over R squared. So E versus R will give us this equation. So the closer the test charge is to the source, the greater the E. The further away the test charge is from the source, the smaller the electric field. And up to infinity, the electric field will be 0. Okay, from this graph lah. Based on this graph, kita akan go towards 0. Memang, that's just math. Okay. And then we have electric field due to a system of charge. So here we talk about vector quantities again. So the field at a point due to more than one charge equals to the vector sum. Tahu ni, we know this. This is the resultant electric field. So here I want to know what is the electric field exerted on this charge by Q2 and by Q1. Okay. Okay, let's do. So I want to know what is the force exerted, what is the electric field exerted on this guy, right? I need to do the same steps as the electric force, which is draw the lines. And then determine which is the direction of the electric field, okay? Ataupun electric force. So here positive with positive repel, this is the direction, and this guy also repels. So E1, E2, and the resultant will be in between E1 and E2. So this is ER or E resultant of Q3 or charge number 3. Now the question is, what goes into our equation? I told you that E is F over Q, and it should be KQ over R squared. What should be put into this equation? What is the value of Q here? Should it be the value of Q3 or Q2 or Q1? Okay, what should be the Q? What should be in the equation for E1? So this is E1, we have E1 and we have E2, right? This is E1, this is E2, repel by Q2, repel by Q1. What should be in the equation of E1? Okay, the electric field is due to a source charge. Sorry, electric field is due to a source charge. So we are interested to know what is our source charge. Aduh. So KQ1 over R squared is our E1. And E2 is the electric field from Q2. Okay, R1, R2 is, this should be 1, 3. Oops. The distance is the same, tak berubah. 1, 2, 3 squared. And this is 2, 2, 3. Terbalik, saya tulis terbalik. 3, 1. And this is 3, 2. Okay. So again, I'm going to repeat myself. The electric field is due to a source charge. We cannot get electric field from a test charge because test charge ni selalunya kecil. So kita nak tahu medan elektrik daripada source charge, daripada sumber charge kita. So here, our electric field is given by Q2 and is given by Q1 and is exerting electric field on charge Q3. So E1 is KQ1 over R31 squared and E2 is KQ2 over R32 squared. Okay, I hope that's clear. Any questions? Okay,
No.
so everyone is okay. If you have questions, nanti boleh tanya. So electric field at a point is a vector quantity. Same thing. We use this. First, we did the direction. Second, we find the magnitude, right? Due to source. It's the same steps as calculating for force, but for electric field. And then find the resultant. Sama je. Okay, direction, magnitude, and resultant. Calculate the resultant field at point P. So this is an example. Tak like example sangat. This is how you do it. So this is the point that we are interested to know what is the electric field there. Now, there's no charge here. How do I find the electric field? How do I know if it's going to repel or if it's going to attract? So how do I know this? How should I do this? I need to figure out the direction. So I want to know at point P. What should I do? Okay, no answer. No one wants to guess. It starts with a T. Starts with a T and E and S. Kasi jawapan penuh je. So you use a test charge, okay? So if I wanted to know what is the electric field at point P, I put a test charge over there. If I want to know what is the electric field at this point, point Q, I put a test charge. What is a test charge? A test charge is a positive charge that is small in value. And you can just ignore the magnitude of this test charge because it's super small. So I just want to know, okay, this test charge is positive. What is the direction? So that is how I'm going to do it. So test charge, positive. Okay, now I can figure out the direction. Draw a line to the charges, to our source charges that causes the electric field. This is positive with, is that a negative? Yes, that is a negative. So I will be attracted to this dude. And this guy is a positive. My test charge is a positive. It's always a positive. It will never be a negative. So this will be it will be repelled and it will go upwards. Okay, so my resultant will be between this guy E1 and E2. This is my resultant ER. Okay. And again, how do we add vectors? We need to resolve them into X components and Y components, and then we find the resultant. Sama je step macam force. Okay. Okay, now we go into electric field lines. It's different than electric field direction. When we talk about electric field direction, we are figuring out what is direction at a certain point. And how do we figure it out? We put a test charge over at that point. For electric field lines, we talk about the source charge. we talk about the source charge. So it's different. We are talking about the source charge now. Tadi kita cakap pasal test charge. Now we are talking about the source charge. Okay, so source charge, the electric field lines for a positive charge is going outwards, and the negative for a negative charge, the electric field lines is going into the charge. So how do we memorize this? Do I have any tips? Kejap saya fikir. I want to give this tip, tapi saya takut korang akan jadi confused. So either you memorize this or be prepared to be confused, I guess. So if I put a test charge here, right, positive charge, test charge, we are talking about source charge. Electric field line memang akan cakap pasal source charge. Always, electric field line cakap pasal source charge. Please burn that in your head. Field line akan cakap pasal source charge. So I want to know what is going on with the source charge. So assuming there is a small positive test charge, tak boleh. Apa? Negative. No, my tip won't work. Okay, never mind. So electric field line positive, it will go outwards. For negative charge, it will go inwards. If I remember what was my tip for previous semester, I will tell you. There was a tip I forgot. Okay, sorry. So number of lines is proportional to the magnitude of the field. So here we have one, this is one, positive 1 coulomb. Let's see. Positive 1 coulomb will have 1, 2, 3, 4, 5, 6, 7. Contoh, contoh ada 7 lines. If I increase the value of this charge to 2 coulomb, this guy has 7 lines. For 2 coulomb, I will have 14 lines. Okay, so the number of lines is proportional to the magnitude of the field. So if I have more lines, it means that my electric field is also greater. Why? Because it depends on Q. So if my Q is bigger, my electric field is bigger, my lines will be more. Okay, so E is proportional to Q, proportional to lines. I think I will end. Okay, dah. Rules for drawing ni, tak apalah, kita buat next class. I think I will end class here. If you have any questions, you can ask me. If you come across a question that you don't understand on the things that we have done, which is electric force and electric field, you can ask me juga. Okay. So that is it for today's class. All the best for your agriculture quiz. Bye-bye.
Thank you.
You're welcome.
Thank you, Doctor.
Welcome.
Thank you.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Welcome, Redo.
Doktor,
Fakri, yes?
kita punya final exam, saya tengok dalam plan tu kan, ada chapter 15.
Ada. So chapter 15 penting.
Macam mana selesai?
Macam mana selesai? Oh, because
Kita kan
sebab kita dah buat kat test nanti. Entahlah. Saya pun tak sure. Tapi hari tu ada reasoning dia, saya lupa lah. Nanti saya tanya balik kenapa kita letak 15. Tapi itulah saya cakap 15 tu penting. Dah lah susah. Okay, all the best.
Okay.
Bye.
Thank you, Doktor.
Welcome.
Doktor.
Yeah.
Apa tu yang saya cakap pasal attendance saya tu untuk 19 dengan 24 Februari.
Oh, 19 dengan 24 kan? Okay, saya buat sekarang. Sementara masih. Welcome. 19 and 24. Bye. Boleh tutup dah ke ni?
Thank you, Doktor.
Main lagi ni. Umay, yang awak tanya pasal degrees tu betul. Tapi saya lupa nak explain tadi. Nanti kita buat example on electric field nanti kita akan touch balik on angles lah. Okay. Yang you
Betul, saya confused.
about
Like, tadi yang kalau kita letak test charge, so like dia punya direction field tu macam mana?
direction field tu macam mana? Soalan tu dia cakap what is the electric field, what is the resultant electric field on that point kan? Point P tu tak? Point P tu tak ada charge. Tapi cara kita untuk kira electric field yang berlaku kat point P is by placing a positive charge there. And step dia semua sama macam force. So kalau repel dia, kalau like charges repel, different charges attract. Lepas tu nanti cari resultant. Kenapa awak tak faham yang test charge tu lah? Dia macam confusing ke?
Sebab tadi saya tengah tengok notes data yang tak tahu tadi macam laju, so bila tak tahu saya confused.
Awak tak buat example lagi kot, betul-betul. Nanti kita buat.
Okay, thank you Doktor.
Welcome, bye. 19 dan 24 Februari. Mariam. Ramai lagi kat sini. Korang tak nak balik ke? Bye.
Thank you, Doktor.
Bye. Saya dah buat tau Mariam. Mariam ke Aisyah? Saya terlupa lah nak panggil awak apa.
Saya Mariam Aisyah.
Mariam. Okay.
Panggil Nur.
Panggil Nur. Nur Mariam Aisyah.
Thank you, Doktor.
Bye. Okay, bye. Saya tutup tau.